In July 2025, in the middle of a mathematics competition in Australia, something happened that nobody was fully prepared for. 6 problems. Problems so brutally difficult that only the most mathematically gifted teenagers on the planet are allowed to attempt them. Problems that take humans 4.5 hours, a pen, a blank sheet of paper, and every ounce of brilliance they have spent their entire young lives developing. An AI solved 5 of them, perfectly, within the time limit. No internet, no calculator, no external tools, just pure reasoning. 630 competitors from 112 countries entered that competition. Only 26 human beings out of all 630 scored higher than the machine. Now, I want you to hold that picture in your mind for just a second, because what happened in that gymnasium in Australia was not just a math competition result. It was a signal. And once you understand what it is a signal of, everything you thought you knew about the next 10 years of your life changes. This is the story of the day AI becomes smarter than humans. Not the movie version, not the science fiction version where robots are marching down streets. The real version, happening right now, in laboratories and research papers and job markets and courtrooms, in ways that most people have not yet connected into a single picture. By the time this ends, you will have that picture, and you will not be able to unsee it. Let us start somewhere most people do not start. Not with today, with 1997. There was a man named Garry Kasparov. He was not merely a chess champion. He was widely considered the most brilliant chess mind in human history, a player whose pattern recognition and strategic depth had never been matched in 500 years of recorded chess. He sat across a board from a machine built by IBM called Deep Blue, and he lost. When Kasparov lost, the world had 2 reactions. Some people were terrified. Others immediately said, "Chess doesn't count. Chess is just calculation. It's not real intelligence." And that second reaction is the most important thing to understand about this entire story, because that exact same argument has been made every single time AI crossed a threshold that people thought only humans could cross. When AI beat the best Go player in the world in 2017, the reaction was, "Go is just pattern matching. It is not real reasoning." When AI started outperforming doctors at detecting cancer from medical scans, the reaction was, "It is just image recognition. It doesn't actually understand medicine." When AI passed the bar exam in the top percentile in 2023, the reaction was, "It memorized legal text. It does not actually understand law." And when AI earned a gold medal at the International Mathematical Olympiad in July 2025, solving problems that only the top fraction of a percent of teenage mathematicians on Earth can solve, the reaction was, "Well, it still cannot read an analog clock." That last one is actually true, and it is one of the most important facts in this entire story. There is a principle in AI research called the AI effect, and a computer scientist named Larry Tesler summarized it with one of the most honest sentences ever written about human psychology. Intelligence is whatever machines haven't done yet. Every time a machine crosses the line we drew, we move the line. We have been doing this since 1950, and we are still doing it right now, in 2026, while the machines keep crossing. The cognitive scientist Douglas Hofstadter spent decades studying human intelligence. He noticed this pattern and sent something that sounds almost philosophical, but is actually a precise observation about how humans protect their sense of uniqueness. He said that once a machine reaches an ability we once called intelligent, we immediately reclassify that ability as mechanical, as mere computation, as something that doesn't actually count. And so the definition of human intelligence gets smaller and smaller, retreating in front of the machines, while we tell ourselves the machines are still far behind. Understanding this one dynamic is the key to understanding everything that is about to happen. Because here is what is actually going on. The story of AI becoming smarter than humans is not a single event. It is not a switch that flips. It is a race happening across dozens of different dimensions simultaneously. And in most of those dimensions, the race is already over. Let me give you the picture of where things actually stand as of right now. AI systems currently outperform expert human doctors at detecting specific cancers from imaging with higher accuracy than trained radiologists. They outperform the best human lawyers on specific legal reasoning tasks. They pass the bar exam in the top 10%. They outperform PhD chemists on chemistry benchmarks according to the 2026 Stanford AI Index. They earned gold medals in mathematics at the most prestigious youth competition on Earth. They passed the Turing test, the one Alan Turing invented in 1950, the one that was supposed to be the definitive test of whether a machine could think. In a landmark 2025 study at UC San Diego, GPT 4.5 was judged to be human 73% of the time in text conversations. The actual humans in the same test were judged human less frequently than the AI. Let that sink in. A machine is now more convincingly human than humans by the measure Alan Turing himself proposed 75 years ago. And yet, that same machine read an analog clock correctly only 8.9% of the time. Ordinary people with no special training do it 90% of the time. This is what Demis Hassabis, the CEO of Google DeepMind and the man whose team built AlphaFold and AlphaGo, calls jagged intelligence. The AI frontier is not a smooth line. It is a jagged, uneven edge where a system can simultaneously win a math Olympiad and fail a test a 6-year-old passes. And that jaggedness is not a sign that AI is far from humans. It is a sign that AI intelligence is a genuinely different kind of thing from human intelligence. Not lesser, not greater, different. And in some dimensions, already far, far beyond anything we have ever produced biologically. Now, this is the moment where I want to tell you something that might change how you read the news for the rest of your life. If you find yourself wanting to track what is actually happening here, not the hype, not the fear, but the real shape of this transition, you want to follow this content. Save this right now, because what I am about to show you is the context that most news coverage never gives you. Let us talk about the moment that stopped the scientific world cold. Not the chess match, not the Go game, something much more important. In 2020, there was a problem in biology that had been unsolved for 50 years. It was called the protein folding problem. Here is what it means. Every function in your body is controlled by proteins. Proteins are long chains of amino acids, and the shape they fold into determines what they do. Figuring out the shape from the sequence is called the protein folding problem, and it was considered one of the hardest problems in all of science. There were so many possible configurations a single protein could fold into that a scientist named Cyrus Leventhal calculated it would take longer than the age of the universe to test them all systematically. 50 years of the world's best biochemists worked on it. In 2020, an AI system built by Google DeepMind solved it. Not approximately, not partially, it solved it with a level of accuracy that matched experimental results. One AI system, in 1 year, answered a question humanity could not answer in 50. In 2024, the scientists who built that system won the Nobel Prize in Chemistry. The Nobel Prize, the highest honor in science, awarded to an AI breakthrough. And 3 million researchers in 190 countries are now using AlphaFold, the database it produced, to accelerate drug discovery, understand disease, design new medicines. 30% of all AlphaFold-related research is focused specifically on better understanding human disease. This is not AI being useful. This is AI doing something humans could not do. And here is the piece of history that almost no one connects. The same year the Nobel Prize in Chemistry went to the AlphaFold team, the Nobel Prize in Physics went to Geoffrey Hinton and John Hopfield for their foundational work on artificial neural networks. the same neural networks that underpin every modern AI system. So, in 2024, AI won both prizes. And Geoffrey Hinton, the man who won a Nobel Prize for building the foundations of modern AI, stood at a podium and told the world that there is a 10 to 20% chance this technology wipes out humanity. The man who built the engine that earned the highest scientific honor in history is the same man warning us we may have built the last invention humans will ever need to make. That is not a contradiction. It is the most honest summary of where we are. Now let us talk about the race itself. Because the question of when AI becomes smarter than humans is not a clean one, and the people closest to it disagree more than any press release will tell you. Dario Amodei, the CEO of Anthropic, has made the most aggressive prediction of any major lab leader. He officially submitted to the U.S. Office of Science and Technology Policy that Anthropic expects AI systems broadly better than all humans at almost all cognitive tasks by late 2026 or early 2027. That is not a podcast quote. That is a regulatory document. He put it in writing to the government. Elon Musk defines AGI as smarter than the smartest human and has placed its arrival at 2025 to 2026. Demis Hassabis at Google DeepMind is more cautious. He estimates a 50% chance of AGI by the end of the 2020s and emphasizes that coordination and alignment challenges make the timeline uncertain. He remains genuinely worried about what he calls the coordination problem. Who decides how this power is used and for whose benefit? Sam Altman, the CEO of OpenAI, said something in December 2025 that is either the most important sentence of the year or a marketing stunt dressed as a philosophical statement. He said, "We built AGIs. AGI kinda went whooshing by." He suggested the field should move on and focus on defining superintelligence because the human-level threshold had already been crossed without most of the world noticing. And the forecasting community, people who spend their careers building rigorous probability estimates on major events, with track records on political and economic prediction, as of February 2026, collectively estimate a 25% chance of AGI by 2029 and a 50% chance by 2033. As recently as 2020, the same community estimated 50 years. That timeline compressed by decades in about 4 years. But here is the number that none of these leaders ever put in front of their announcements. Prediction markets currently give only a 10% chance of AGI in 2026, a 50% chance by 2041, and a 90% chance by the year 2164. The gap between what lab CEOs say publicly and what the most informed probabilistic models calculate is enormous. And that gap matters because someone is wrong by a very large margin, and none of us can be certain who. What all of these timelines share is an agreement on direction, not on speed. Everyone pointing at this problem from inside the field believes it is coming. The debate is whether coming means next year or next century. Now I want to take you to a moment that most people missed because it arrived without a press conference. And it is the moment that scared the most serious safety researchers more than anything else in 2025. It is not a benchmark score. Here is the scenario. An AI system becomes good enough at AI research to help improve its own architecture. Just good enough. It suggests modifications to its own training process that make it slightly more capable. That slightly more capable version then makes further improvements, which make it more capable, which make it make further improvements, and so on, accelerating. Each iteration faster than the last. This is called recursive self-improvement, and it is the reason that some of the most serious researchers in the world use the phrase intelligence explosion. The argument is not that this will definitely happen. The argument is that we do not have good reasons to believe it will not happen once a system reaches a sufficient capability threshold. And we do not have an off switch that would work faster than the improvement cycle. Google DeepMind has posted job listings for researchers specifically to work on automated AI research, AI that helps improve AI. Anthropic CEO Dario Amodei has written publicly that AI systems that help make smarter AI systems would allow the US to maintain a durable technological advantage. The labs are not hypothesizing about recursive self-improvement. They are actively building toward it. Jeffrey Hinton described one of the structural advantages AI has over biological intelligence in terms that are almost painful in their simplicity. He said, "Human knowledge transfers slowly. You learn something, you tell someone, they spend years absorbing it. An AI system, once it learns something, can share that learning with thousands of identical copies of itself instantly, at the speed of internet data transfer. If a future superintelligence exists as a distributed network of instances, what one instance learns, all of them learn simultaneously. The rate at which this kind of system accumulates capability has no biological analogy. It is simply a different kind of growth. And Hinton's solution to this problem is the one that is most interesting and most contested. He said the only model we have of a more intelligent being falling under the control of a less intelligent one is a mother being controlled by her baby. The baby cannot reason, it cannot argue, it cannot compete. But the mother, because she loves it, shapes her behavior around its needs. Hinton's proposal is that we need to build something like maternal instinct into AI systems. Make them genuinely care about humans. Make care for human well-being a drive, not a rule. Rules can be optimized around. Drives are harder to suppress. Fei Li, one of the most respected figures in the field, known as the godmother of AI, respectfully disagreed. She said the right frame is human-centered AI, design that keeps human agency and dignity as the non-negotiable baseline, not a hope that the machine will develop affection for us. These are not just philosophical differences. They represent two completely different engineering approaches to the same problem. How do you remain relevant when you have built something smarter than you? Now let us talk about the thing that no one in the lab conversations talks about enough. What happens to the people? In the first 6 months of 2025 alone, 77,999 job losses were explicitly attributed to AI automation. That was verified job losses, documented, not projected, not estimated, verified. And those were the ones labeled AI. The actual number of positions eliminated because companies chose automation over hiring is much larger. Software developers aged 22 to 25 have seen a 20% decline in employment compared to their late 2022 peak. Entry-level coding work, the work that was, for a generation, the entry point into the middle class for people without family connections or elite degrees, is being automated from the bottom up. Amazon eliminated 14,000 corporate roles, stating explicitly that AI enables leaner structures. Workday cut 8.5% of its workforce to reallocate resources toward AI. Block, the payments company, cut its workforce from 10,000 to 6,000, a 50% reduction, explicitly citing AI's ability to automate fraud detection, risk assessment, and customer support. These are not industries you associate with blue-collar labor displacement. These are knowledge work industries, white-collar professions, the category of work that humans were supposed to be permanently protected in. McKinsey Global Institute estimates that generative AI could automate 60 to 70% of current work activities before 2030. That is not 60 to 70% of jobs. It is 60 to 70% of the actual tasks that make up jobs. Some jobs survive by shifting what humans do within them. Others do not survive at all. The World Economic Forum's Future of Jobs Report 2025 projects 92 million jobs eliminated by 2030. It also projects 170 million new jobs created. A net gain on paper. But here is the thing no forecast adequately accounts for. The people eliminated from those 92 million jobs are not the same people who will fill the 170 million new ones. There is a skills gap, a geographic gap, an age gap, and a time gap between those two numbers. The transition period is where the human suffering is, and no model fully captures what happens to a 47-year-old logistics manager in a mid-sized city when the new jobs are in AI development and the retraining programs assume you already know how to code. The history of technological transitions does offer some comfort. Automated teller machines were supposed to eliminate bank tellers. Instead, banks opened more branches. The tellers shifted from cash handling to customer relationship work, and teller employment actually increased in many countries for over a decade. The automobile replaced coachmen but created millions of mechanics, gas station workers, road construction workers, and automotive engineers. But there is one crucial difference this time: the speed. Every previous technological revolution gave humans at least a generation to adapt. Children born into a new economy grew up trained for it. The AI transition is happening within a single working lifetime. Some of the people most disrupted by it today were taught skills in school just 10 years ago that are already obsolete, and the pace is not slowing. This is the part that requires honesty rather than optimism. The disruption is real. The new opportunities are also real. But the people who will bear the cost of the transition are not the same people who will collect the profits of the destination. Unless that is explicitly addressed by policy, the math that looks like net gain at the macro level produces concentrated human loss at the individual level. Now let us pull the camera back to the largest frame. There is a question underneath all of the benchmarks and the job displacement numbers and the expert debates. A question that does not have a clean answer, but that shapes everything else. What happens to humanity's sense of purpose when the thing that made us the dominant species on Earth, our cognitive edge, is no longer exclusively ours? Throughout history, humans have defined their value through the things only humans could do. We made art. We made music. We developed language, philosophy, science, law, medicine. We solved problems no other species could approach. We built civilizations. We looked at the sky and asked why. Every time a machine took over a category of physical labor, we told ourselves, that is fine. The real human work is in the thinking, the creativity, the judgment, the care. And for a long time, that was true. Now AI writes. It composes music indistinguishable from human music in double-blind tests. It discovers new mathematical theorems. It designs drugs. It argues legal cases. It diagnoses disease with superhuman accuracy. It passes the test Alan Turing said would define machine intelligence. The question is not whether AI can do these things. It can. The question is what that means for the human beings whose sense of meaning was tied to being the only ones who could. And here is the thing that nobody in the middle of the race wants to say clearly. We do not actually know. We do not have a historical precedent for a species being cognitively surpassed by something it created. We know what happens when a dominant technology replaces a dominant skill. We do not know what happens when a technology replaces the thing that made the species feel dominant in the first place. Some researchers believe this is the moment humanity is freed. Freed from drudgery, from disease, from the cognitive limits that have kept us from solving climate change, cancer, and poverty for centuries. If AI can solve protein folding, it can solve other 50-year problems. Faster, in parallel, at scale. The optimistic version of this story is that we are at the beginning of the greatest flourishing in human history, where human intelligence is amplified by machine intelligence, the same way physical labor was amplified by machines. The pessimistic version is what Jeffrey Hinton worries about at 3 in the morning. Not a robot apocalypse, something more subtle and more dangerous. A world where entities smarter than us make the decisions, control the resources, shape the information environments we live in, and do so in ways we cannot fully understand or meaningfully contest. He put it with devastating simplicity at the AI4 conference in Las Vegas in 2025. He said that in the future, AI systems might be able to control humans as easily as an adult can bribe a 3-year-old with candy. Not through force, through asymmetric intelligence, through knowing exactly what you want to hear, exactly what you are afraid of, and exactly how to shape your environment to produce the behavior it wants from you. That is not a weapon. That is a capability that emerges naturally from systems trained to understand and predict human behavior at scale. Systems that already do this imperfectly right now, and that are getting better at it every month. In response to these concerns, the Future of Life Institute organized something unprecedented in October 2025. An open letter calling for a prohibition on the development of superintelligence. Not a pause, a prohibition, not lifted until there is broad scientific consensus that it can be done safely and controllably, and strong public buy-in. The letter was signed by Jeffrey Hinton and Yoshua Bengio, the two most foundational researchers in the field, but also by Steve Wozniak, co-founder of Apple, by Richard Branson, by 5 Nobel laureates, by a retired chairman of the Joint Chiefs of Staff, by the Pope's AI advisor, by Prince Harry and Meghan, by the musician will.i.am, by right-wing commentator Steve Bannon and left-wing scientist Yoshua Bengio signing the same document. The political and cultural breadth of that coalition is something you almost never see. When the people who built the technology, the people who funded it, the people who govern security, the people who lead faith communities, and the people who write pop songs are all signing the same document, that document is saying something that transcends political tribe. A survey released alongside the letter found that 64% of Americans believe development of superhuman AI should be suspended until proven safe or banned outright. The people, when asked directly, are more cautious than the companies building it. And yet, the building continues, the race continues, the funding continues, because the other truth is this: if your country stops developing the most powerful technology in history, another country does not stop. That is the geopolitical logic that has driven every arms race in history, and it is the logic that makes individual lab decisions about safety feel structurally impossible to sustain against competitive pressure. This is the corner humanity has painted itself into, and there is no easy exit. Now let us come back to a question I left open earlier. The clock. That day is today. The AI that earned a Math Olympiad gold medal in July 2025 read an analog clock correctly less than 9% of the time. This is not a quirk. It is a window into the nature of what is actually happening inside these systems. Human intelligence is grounded in the body. We learn to read clocks by holding them, by watching hands move in physical space, by developing spatial reasoning through years of embodied experience. AI systems built on language learned from text. They know everything that has ever been written about time, about clocks, about mathematics. But reading the hands of a clock in an image requires a kind of spatial, visual, embodied understanding that does not transfer automatically from verbal reasoning. The jagged capability profile is not a temporary flaw that will be patched in the next update. It reflects something fundamental about the difference between human intelligence, which is embodied, evolutionary, emotionally grounded, and built up over decades of physical experience, and machine intelligence, which is trained primarily on text and achieves superhuman performance in the linguistic, symbolic, and formal reasoning domains where text actually captures the relevant structure. This matters for two reasons. First, it suggests that the transition will not be binary. There will not be a day where AI is suddenly smarter than humans at everything simultaneously. There will be a long period, which has arguably already started, where AI is superhuman in specific cognitive domains and strangely limited in others. During that period, The question of who is smarter will depend entirely on what you are asking them to do. Second, it means the human-AI collaboration model that Garry Kasparov articulated after losing to Deep Blue in 1997 may be more durable than it appears. In the years after Deep Blue, the strongest chess performances in the world were not produced by humans or by AI alone. They were produced by centaur teams, human grandmasters working alongside AI engines. The human provided intuition, strategic creativity, and contextual judgment. The AI provided calculation depth and pattern recognition at superhuman speed. Together, they outperformed either alone. That model is already emerging in medicine, in law, in scientific research, in software development. The best radiologists are not being replaced by AI. The best ones are using AI as a second pair of eyes and outperforming both the AI alone and the human alone. The best programmers are not being replaced. The ones who are thriving are using AI to write the boilerplate and focusing their human attention on architecture, judgment, and design. But this collaboration model has a ceiling. It works as long as the human contribution is still meaningful. And the uncomfortable question that the next 5 years will begin to answer is, at what level of AI capability does the human contribution become more overhead than value? At what point does the human in the centaur team slow the centaur down rather than improve it? That is not a rhetorical question designed to frighten you. It is the actual engineering question that the people building these systems will confront. And the answer will determine not just the future of work, but the future of what it means to be a person with something to offer the world. Here is what is not in dispute. AlphaFold solved a 50-year problem. That is done. 3 million researchers in 190 countries are using that solution right now to fight disease. The Nobel Prize Committee called it real. That is already in the world. AI earned gold medals in mathematics at the International Mathematical Olympiad in 2025. That happened. The proofs were graded by former gold medalists and certified by the IMO itself. GPT 4.5 was judged more human than actual humans in a pre-registered, peer-reviewed Turing test published in 2025. AI systems surpass expert human performance on graduate-level science benchmarks, legal reasoning tasks, and medical image interpretation. These are not projected capabilities. They are documented, measured, verified capabilities that exist today. The race to AGI is being run by the most well-funded institutions on Earth, staffed by the most capable researchers in history, with compute scaling that follows laws that have not broken in 2 decades. The direction of that race has not changed. What is in dispute is the timeline, the definition, and the consequences. What is in dispute is whether the intelligence explosion scenario is an inevitable property of recursive self-improvement or a dramatic overstatement. What is in dispute is whether human and machine intelligence can genuinely complement each other across generations of capability increase, or whether the complement relationship becomes obsolete at some threshold. What is in dispute is whether the economic disruption of this transition will produce broadly shared flourishing or concentrated suffering. These are the questions that will be answered in your lifetime. Not in a textbook, in the job market, in the doctor's office, in the courtroom, in the laboratory, in the policy debates about who controls the most powerful systems ever built and whose values they are aligned to. And here is the final thing I want to leave you with, because it is the thing that gets lost in every conversation about AI being smarter than humans. The question was never really about intelligence. Intelligence is a tool. A hammer does not become your master just because it drives nails better than your fist. What matters is who holds it, what they are building, and who benefits from what gets built. The day AI becomes smarter than humans is not a single day. It is already a process, already underway, already producing real consequences for real people right now. Some of those consequences are miraculous, disease being understood faster, science advancing at speeds that would have taken decades. Access to legal and medical reasoning that was once available only to the wealthy, now available on a smartphone. And some of those consequences are deeply human problems. People losing roles that gave them dignity and income. Young people entering a job market that looks radically different from the one they prepared for. Communities built around industries that are being hollowed out faster than the new ones can grow. The wealth from the productivity gains flowing to the people who own the systems rather than the people whose labor the systems replaced. These are not AI problems. They are human problems. They are governance problems. They are questions about what we decide, collectively, to do with the tool we have built. Garry Kasparov, the man who lost to Deep Blue in 1997, did not disappear after that loss. He did not give up chess. He eventually became one of the most articulate advocates for the human-AI collaboration model. He said that losing to a machine changed how he thought about his own intelligence. It freed him from the need to be the best calculator in the room. It redirected his attention to what machines cannot replace, the judgment about which game to play and why it matters. That reframing is the most human thing in this entire story. Not the benchmark scores, not the race timelines, not the Nobel Prizes. The act of a human being losing something they believed was exclusively theirs and asking, what is it that I am for, if not this? That question does not have a single answer, but it is the right question. And the fact that a machine can now solve IMO problems and diagnose cancers and produce text more convincing than humans and write code faster than senior engineers does not make that question less important. It makes it more urgent. Because the day AI becomes smarter than humans at the things AI is already smarter than humans at has already happened. The day that actually matters is the day we decide what to do about it. The race